Hi everyone, welcome back to my channel. I'm Conin Cosmo, and in today's video we're going to start building a Sokoban game in C. So Sokoban, you might be familiar with this game. It's a puzzle where you're a little character and you can push crates around, and your goal is to place them all on those green dots. And in fact it's quite difficult to figure out what is the correct sequence of operation to do. Here for instance, well, I rehearsed before starting shooting this video, so I'm a bit cheating, but you have to do something a bit convoluted, where you go like that in an order which is not necessarily the one in which we would have done things first. Okay, so we're going to build this game, and a nice property of this game is that on the internet you find a lot of levels that people have designed over the years and would send each other on email lists, and so you can find really a big variety of such files where basically this describes what is a level, and this description is actually specified on Wikipedia. So everyone kind of speaks the same language, and our game is going to use this language. And so that we'll be able to play any Sokoban game that has ever been specified that way. To build the game, we're going to use a very popular C library called the SDL that was used, for instance, to make a game like Half-Life. So it's like very robust, and we're going to install it by using a package manager. You know, like in Python there is pip, in JS you have npm and yarn. In C there are some package manager, and here we're going to use one which is called Conan. It's a package manager. The advantage is that we'll all be working with the same version of everything, and it will be like a better practice for development. So here for instance you can see all the package that you can install with this package manager. Okay, because this packet manager is not that standard, I'm going to walk you through the steps to install it and get going. And so here I'm running it on a Linux machine, but I'll put links in the description if you're on Mac or Windows to get going as well. So here I've created an empty folder. I've called it for our project Sokoban C, so there's literally nothing in it. And first we're going to install our packet manager. So how it's going to go, we're going to do this through Python pip, because actually Conan was developed in Python. You just need Python more than 3, that's all. And it's going to go pip install Conan. So here we put the password. And pretty quickly you should end up with the thing installed on your system. We can check, because now Conan says something. In order to get going, the thing that I didn't tell you is that actually the library that we need, SDL, is not on their repository. So, but fortunately there is another repository which is called Bincrafters of people that have actually added SDL to the package manager. So we need to instruct the package manager to look that way. And again, I put link in the description of the video, but we need to copy this command, which I'm going to copy now, which basically says like add Bincrafter to the list of source that you're looking at. So that's done. And then for a reason that I quite not understand, but that's in their doc, so I'm doing it, you need to add this command. Okay, so now we're fine, and we can start using the packet manager. And to use the packet manager, what does it mean? But first we're going to open VS Code. So here I am, and in the folder it's completely empty, and I'm going to create a file which I call a Conan file. And then it's like quite common to all packet manager, in the sense that we're going to say what we want, which is SDL2. That's the library that we want to install and all its dependencies. That's what the packet manager is going to do for us on this remote repository, which is called Bincrafters, and we want the stable version. Okay, and then we want to instruct Conan to create files that we can use in CMake, which will be the program that we use to build our game. Okay, so from there we can simply make our build directory, and the magic of the package manager starts playing here, because we just have to do conan install, and here it starts thinking and install our SDL library. While it's doing this, so we're going to do something else, which is do a bit of custom configuration for VS Code on that project. Setting.json, it's going to look like that. So basically we're going to instruct VS Code to format our files whenever we save them, and not when we type, because that's something that I find really annoying. We're going to set tab size to 2, and we're going to use a program called clong format, and say that we use the coding convention of Google. To see what has been done here, we can actually use their API to generate something nice, I believe, which is this tree, and we see the kind of the power of the package manager that starting from this conan file figured out where to find SDL and install all the relative dependency to SDL, and it did all that. So that's nice, and it did more because it created a configuration that we're going to use right now for CMake. So now we're going to do everything from VS Code, and we're going to start just by putting some actual code in our project. So we're going to create a src file and a main.c file, and here we're going to include our SDL. So SDL2 SDL.h, and we're going to have an empty main function which will just return 0. So here you see VS Code is not happy, saying, hey, where is SDL2? But thanks to this setting, in a little while, just right now, thanks to these settings and the fact that we tell to VS Code, hey, go look for SDL in that file, that folder, now VS Code is up to date and will benefit from IntelliSense and all the nice features in a little minute. Now we're just looking to build our project, so we're going to use, as I was saying, CMake. So CMake is quite an heavy machine, and actually I have to admit that I don't understand it really well, but it's a way to specify our project. So you need to start saying what version of CMake you want to use. Here we're going to use 2.8.12, I believe, and create a project, which is our project, which is called Sokoban. Okay, we're going to tell our compiler that we work with C11. And then we're going to include this magical file that was created by Conan. So if we take a glance at it, basically it's a file that Conan generated where all the information about SDL, for instance, is stored. So here you see it said where to fetch it and where to fetch everything. So it's there, we've linked it in our project, and then we just run the basic setup. And now we just have to tell what are the files that we're going to compile, and they are all in the src folder. So we just say compile any C file in the src folder and create an executable called Sokoban C out of the source. We need to link all the libraries to our project, and this is done kind of really easily thanks to Conan again, because we just use this variable that was created for us. So this will contain all the library used in that project here, mainly SDL. Okay, so we are pretty much good to go, and we can test this here by going into the build and CMake. Okay, from this operation we have a make file that was done, so we can just make, and now we have our target which has been created, and we can just do bin Sokoban C, and nothing's happened because we've put nothing in the main.c file. We're going to put something right now, which is kind of a standard architecture for SDL programs, is that you start by having a window, SDL window, and then you init the whole library with this flag, init video. From there, you declare your window. So that's just going to be a bunch of code that I'm going to copy right now. So basically, you create a video by, say, putting the caption. So here it's going to be Sokoban, the dimensions. And here that's actually the XY position of the window, but we don't want to specify this. So it's just go to undefined, and that's the backend, which is going to be the OpenGL engine. Okay, and now what we can do, for instance, is simply to first check for errors, because we have kind of no guarantees that the window is going to be created. So we check if the pointer is null, and if it's null, we say something like could not create window. The SDL library will give us an error that we can use. That should be SDL get error. So the user will have a bit of debugging information. We return a negative status, a failure status code, which is 1. And then, for instance, we just wait for a few seconds. So that's specified in milliseconds, so that will be 3 seconds. And then we clean up our mess by destroying the window. So we disallocate the memory for the window, and we clean the library. Okay, so hopefully that should work. And here you can see that maybe for people that are not familiar with the thing that we did for CLang format, is that if I'm trying to mess around with the formatting of the document and do something ugly, now each time I save, I end up being in the format that Google specified, I suppose, to their engineers. Okay, so from there we just have to make and execute our program. And here we are at the beginning of our Sokoban. So we're almost done for today. So the only thing that we're going to do in anticipation is that our game is going to have assets, so images and stuff that are going to be put on the screen, like the character and everything else. So we're going to create an asset folder, assets, in which we'll have all our images and stuff. At the minute, it's going to be empty, but we are going to tell CMake to put it where our binary is, because there's no way our binary is going to reach those assets if the asset folder is not put next to it. And for doing so, what we're going to do is actually we're going to make a link, and this is some code that I just found on Stack Overflow to do it. But basically, we're going to link this asset folder into our bin executable folder. So just to see this in a very practical way, now if we do CMake and make, you see we have one more step on more than the compilation, which is the symbolic link for the resource folder. And what has happened is that now here we end up, if we lsbin, we have our program, but also a symbolic link to this asset folders that will contain all our images, and so we'll be able to read them from our game when the game is running. So that's kind of it for today. Thank you very much for tuning in, and next time we'll be focused on the game logic, more particularly in building the model for the game and being able to read those levels that we've seen when we've started. So to parse those level files and get going with our Sokoban game. Thank you very much, and see you next time.